Hello all and welcome back. In this video, I'm going to talk about classes in details. We will talk about what are classes, why do we need classes, what are properties, methods and events with respect to classes. In fact, this video will be the building block for my next video, which will talk about OOP, which is object-oriented programming. So if you're not aware what a class is and how the classes work, then I highly recommend watching this video. In fact, I'm going to use a car example and I'll talk about tires, fuel, engine, etc. to explain about classes. So let's begin. A class is a template of an object, which means that you can use class module to create your own custom objects. Think of it like this. A car is an object and a class is a design. The object is created from that design. We will talk about object in detail when I talk about object-oriented programming in my next video. However, in a nutshell, an object is used to represent real-world or computer-based items. If we take an example of, let's say, Microsoft Excel, then a worksheet, a cell, a chart, a user form, etc. are examples of object. The objects may have properties, methods, and events. If I need to define them, let's say in one line, then I would say properties define the state of the object. Methods define the behavior of the object. And events define the change in the state of the object. Let's understand all of this in detail. Let's quickly launch the Visual Basic Editor by pressing the shortcut key Alt F11. If you're not sure what Visual Basic Editor is, then I recommend watching the video Visual Basic Editor and Introduction. Before we get into classes, let's start by inserting a module. Right-click on the VBA project and then under Insert, click on Module. Few moments ago, I briefly explained about classes and objects using a car example. Let's continue using the car analogy to understand classes in detail. I'm going to create a basic procedure and I'll call it My Car Experience. This procedure will consist of other procedures which will contribute to my overall car experience. Okay, so let's begin. Sub My Car Experience. So what I will do is the first one is to manufacture or create my car. So create new car. The next thing is once the car is created, we will fill fuel in that. So I'll call it fill fuel. Then what we will do is once the fuel is filled, then we will drive the car. So I will type drive the car and we are done. Let's also create individual procedures for this. Currently they'll be empty, but later on we will fill them up. Now we are ready to work with our class. In this class, we will create certain properties, methods, events of the car that we can use in the module for our car experience. To drive the car, we will consider few basic things. We will first create it, we will then fill petrol, we will then start ignition, we will then change the gear, we will then accelerate the car, and then we will deaccelerate the car. Finally, we will stop ignition. So all these will be part of our car experience. And to achieve all these, we will use properties, methods, and events. So as we delve deeper into the car example, the concept of properties, methods, and events will become much clearer. Let's insert a class module. So we'll do the same thing, right-click on the VBA project. Under Insert, we will click on Class Module. If this is the first class that you have inserted, then Excel will name it as Class 1. You can change the name of the class in the Properties window. I've spoken about this as well in the video Visual Basic Editor and Introduction. So, if you have not seen that video and are not very proficient with the Visual Basic Editor, then I highly recommend watching that video first. Let's name our class as Car. We will begin with properties first. Now I could have used public variables or fields, but I'm using properties because I do not want to expose the data of the class. Properties will simply hide the details of the implementation from the user, which is a good thing because I do not want the user to be bothered with unnecessary details. For example, as a normal user, and I repeat, a normal user, you may not want to know what happens under the hood when the ignition is pressed or when you change gears. You simply want to drive the car. So, the good thing about properties compared to exposing fields or implementation directly is that you can conditionally serve the data. We will go into much more detail when I talk about encapsulation in the next video, which is object-oriented programming in VBA. The class module properties has three components: get, let, and set. Let's understand these in detail. Get returns an object or value from the class. The basic syntax or format, if I may say so, for writing get is public property get, property name as type, end property. Let sets a value in the class. The property let is used for normal data types, for example, string, long, boolean, double, etc. Just like get, let is also written as public property let, property name, var name as type, end property. Set sets an object in the class. The property set is for the objects, for example, class instances. We will come to this in a short moment. Set is written as public property set, property name, var name as type, and end property. So as I write different codes, you will see that I'll repeat these syntaxes very often. The purpose of using these properties is to enable the user to get and set values. Now in our example, what could be the values that we can set? Let me quickly type the code and then I will explain it. And we are done. Here I have created 6 properties to create my new car. For this example, we will use make of the car, model of the car, fuel type for what kind of fuel does it use, fuel level, fuel capacity, and speed of the car. Here I have used get and let for these properties. For example, I'm using get and let for the make of the car. Similarly, I have get and let for model of the car, fuel type, fuel level, fuel capacity, and max speed of the car. It uses the same syntax which I showed few moments earlier. Now let's create an object of the class. So let's go back to the module. To create an object of this class, simply type dim and then the name of the object. Let's call the object the car as car. That's the name of our class. The car is our object which represents a real world car but with limited properties that we created. So in the procedure create new car, we will create a new car by assigning properties. So first we will initialize this object. So I will type set the car is equal to new car. Once this is done, then I will use the with and with statement to assign the properties. Now notice what happens the moment I press the period, which is also called a dot. You notice how the properties of the car are presented to us? This is what we created in the class. Let's start with the make of the car. Let's assume that it is a Ford. So I start typing make is equal to Ford. And the next property that we will tweak is model. Let's say this is a Figo, Ford Figo. And let's say this car runs on petrol. So fuel type is equal to petrol. Usually a car has about 40 liters fuel tank capacity. So let's take that as an example and let's set the fuel capacity of our car as 40 liters. And since this is the new car that is being created, obviously it will have no fuel. So we will set the fuel level as 0. And finally, let's say the maximum speed this car can go up to is 160 kilometers per hour. So I will set the property max speed is equal to 160. Now we have set the values of the properties. So let's check if they have been set correctly. I will insert a message box to retrieve these values and also inform the user that the car has been manufactured. So what I will do is I will insert a message box here. I will type msg box the car ampersand dot make ampersand ampersand, and then I will use the line continuation character to flow the code into the next line. Dot model ampersand has been created. Okay, and we are done. Let's run the procedure car experience and let's see what happens. Obviously the procedure fill fuel and drive the car will also run, but since they are empty, nothing will happen. One more thing before we go ahead and we run the procedure. Since we are initializing the car object, let's also destroy the object once we have achieved our objective. However, instead of destroying the object in the new car, we will destroy the object in my car experience. So what I will do here is I will type set the car is equal to nothing. This line will destroy or release the object that we created in the computer's memory. Okay, now let's go ahead and let's run this. To run the code, click on the Run Sub User Form button or simply press the shortcut key F5. And there you go. The values of the properties are set and we get the values via the message box. So we used two properties in the message box. One was the make and the other was model. And both of them can be seen in this message box. So I hope this example explains how to use the properties and how to create an object of the class. You may have noticed that I have not used the property set in the car class. I've only used get and let. I will be using that property in a short while. Now let's move on to the next characteristic of the object, which is method. Methods are actions that can be performed by the object. Like I mentioned earlier, the behavior of an object is defined by its methods. They are like subroutines or functions. Methods can be of two types. One that just performs an action like a subprocedure, and the other which performs an action and returns a result of the action to the caller just like a function procedure. If you're not sure what subroutines and functions are, then I recommend watching the video What are subprocedures and function procedures. Okay, now we have our car ready. What it needs now is fuel. Since this car mimics a real car, the fuel tank of our car should mimic the fuel tank of the real car. So what I will do now is I will insert a procedure which will validate the fuel that we will fill in the car. Let me quickly write the code and then I'll explain what is happening here. And we are done. Here I have a procedure that will accept an input using a parameter called quantity. In this line, I'm using the fuel level to get the existing fuel in the car. Obviously, when we run the procedure for the first time, the value will be 0 as there is no fuel in the car. So what I'm doing here is I'm checking if existing fuel and the fuel that we are adding does not exceed the tank capacity. And if it does, then I'm informing the user that the fuel capacity of the car is 40 liters and the quantity, whatever quantity that we are adding, will overflow the tank. Here I am checking if the user is passing a negative value. Obviously, you cannot put negative fuel in the car. And here, if everything is okay, then I'm adding the quantity to existing fuel level, and that becomes my new fuel level. So let's go back to the module and let's fill fuel in our car. So I'm going to use the fill fuel procedure. Let me press enter a couple of times so that it comes right up here. Okay. To fill fuel, we will use the method add fuel that we just created. So let's start typing the car dot, and then we can either type add fuel or we can select it from the list. Notice this icon that you get when you press the dot. So visually you can identify which is a method and which is a property. Let's go ahead and let's select add fuel and let's add, let's say 10 liters. Now let's go ahead and let's run this. The car Ford Figo has been created. 10 liters have been added. The car now has 10 liters. Now I want to demonstrate something to you. So what I'm going to do is I'm going to comment this code. The reason why I'm doing this is I want to show you what happens when you keep on adding fuel. And if I do not comment this, then the object will be destroyed every time the procedure is run and the fuel level will be set to 0 next time when we run it. So now when I'm not destroying the car, and since I've declared the object outside right on top, the object will not be destroyed and the fuel level will keep on increasing. So let's run this. Okay, I've got 10 liters. Now I'm going to run the fill fuel procedure again. See what happens. 10 liters have been added. The car now has 20 liters. Now what would happen if I try to add, let's say 30 liters? Remember the fuel capacity is 40 liters and we are now trying to add 30 liters. The current fuel level is 20 liters. Okay, let's run this. The fuel capacity of the car is 40 liters. The 30 liters fuel that you are trying to add will overflow the tank because we already have 20 liters in the tank, which will make it 50 liters. Great. Now we have manufactured the car, we have filled petrol. It is now time to drive the car. To drive the car, we will follow a very basic concept. This basic concept is for this video tutorial only and obviously doesn't exactly mimic real world scenario. So to drive the car, what we will do is we will start the ignition, we will move the gear up, then we will accelerate, then we will move the gear down, then we will deaccelerate, and finally we will stop the ignition. We will also assume that the car has 5 gears. Like I said, we will follow a very basic concept, so there is no reverse gear. We will just use 1 to 5 gears for demonstration purpose. 0 will obviously be the neutral gear. Now, an object can contain more independent objects inside it. For example, a car can have an engine, a body, gears, etc., which are all independent in themselves, but work together to make the car fully functional. So, what we will do is we will create a new independent class for gears. So let's go ahead and let's insert a new class. We will call this class gear. Let me quickly write the code and then I will explain what is happening here. And we are done. Here I have declared a variable for current gear. Here I have created a property for the gear number and I am using the get and the let property to assign and retrieve values as I did in the car class. Here I have two functions. One is for gear up, the other is for gear down. So let's understand what gear up is doing. In this function, what I'm doing is I'm checking if the gear number is less than 5. Now our car has 5 gears. So if it is less than 5, then I'm increasing it by 1. And then I'm setting gear up as true, which means that the gear has been moved up. And finally, I'm showing a message box, gear moved from a lower gear to a higher gear, whatever the number is. And if the gear number is not less than 5, then I'm showing a message box, top gear reached. Just like I have gear up, I have gear down. Here I'm checking if the gear number is greater than 0. If it is greater than 0, then I'm reducing 1 from it. And then I'm setting gear down as true. Finally, I am displaying a message box, gear moved from a higher gear to a lower gear. And if the gear number is not greater than 0, then I'm displaying a message box that the gear is in neutral. Now we will use this gear class in our car class. Let's go to the car class. Again, let me quickly write the code and then I will explain what is happening here. And we are done. Here I have declared an object variable for our class gear. Here I have declared a variable to check if the car is started or not. And here I am using the public property get to set the gear to the car gear. Let's scroll down. Here I have a function procedure called start car. This function procedure is to start the car. The first thing that I'm doing in this function is to check the fuel level. If the fuel level is 0, that means the car does not have fuel. And I am informing the user to fill fuel first, because without the fuel, the car cannot start. And here I'm setting is car started as true. So this will ensure that the other procedures or functions, they know that the car has started. And once that is done, this start car is also set to true, so that this function returns true, which means the car has started. And since the car is starting, I have current car speed as 0 and the car gear number as 0. Finally, I'm showing the message box, ignition is turned on. Just like I have the function procedure start car, I have a sub procedure stop car. In that, I'm setting the current car speed to 0. I'm setting the car gear number as 0. I'm setting is car started as false, which means the car has stopped. Finally, I'm showing the message box that ignition is turned off. Below this procedure, I have another procedure called accelerate to. This procedure is to accelerate the car. This uses the parameter increase speed to accept input from the user to accelerate the car. Here I'm checking if the car has started or not. So this is the variable that I was setting to true in start car. So if this is true, that means the car has started. If not, that means the car has not started and I inform the user to start the car. Okay, in this line, I am checking if the input given by the user, which is increase speed to, is greater than the max speed. If it is greater than max speed, then I'm setting the current car speed as the max speed. That is because the car cannot go beyond the max speed. And finally, I'm showing the message box that max speed has reached and the car cannot accelerate any further. If the increased speed to is not greater than max speed, then I'm setting the new speed as the current car speed. And finally, I'm showing the message box accelerating the new car speed is whatever the input is. Just like I have accelerate to, I also have another procedure called deaccelerate to. This is to reduce the speed of the car. Again, I'm checking if the car has started or not. Here I am checking if the input given by the user, which is reduce speed to, is less than 0. If it is less than 0, that means the current car speed is 0 and the car is standstill. Else, I'm setting the new reduced speed to the current car speed and I am informing the user that the car is deaccelerating and the new car speed is the new reduced speed to. Now let's use these methods in our module to drive the car. Let's go to the module. Let me uncomment this line and let's go to the drive the car. So I'm going to use the with statement again. So with the car end with. So to drive the car needs to be started first. So start car, that's our method, and we'll end with stop car. In between, we will accelerate and deaccelerate the car by changing the gear numbers. So the first step is to increase the gear number. So dot the gear dot gear up. Okay. Once the gear is up, I'm going to accelerate it to, let's say, a speed of 10. Now this is the first gear. Similarly, let's do one thing. This will be for the second gear. This will be for third, fourth, and fifth gear. Let's do one thing. Let's gear up one more time. Let's see what happens. So first speed 10, second speed 50, third speed 100. Then let's say we increase it to 120, then 155, and then 200. Remember, the max speed is 160 km, but we are trying to pass a value which is 200, and that too after the fifth gear. Let's see what happens. Similarly, what we'll do is we'll also deaccelerate once the max speed is reached. So we will gear down. So dot the gear dot gear down. And then we will deaccelerate to 155. Just like I geared up and increased the speed gradually, similarly I will gear down and deaccelerate gradually. So let me copy this and paste it here. And let's say I reduce the speed to 120 kilometers per hour. Then I reduce it to, let's say, 60. Then to 30. And then to 0. Okay. And now let's run this procedure. Let's see what happens. In fact, my cursor is in sub car experience, so this procedure will run. But what I'll do is I'll scroll down so that when the message boxes come, we can compare it to drive the car statements. So I run the procedure. It says the car Ford Figo has been created. 30 liters have been added. The car now has 30 liters. Ignition is turned on. So this message, ignition is turned on, is because of dot star car. Okay, let's press enter key. Gear moved from 0 to 1. This is because of this gear up. Accelerating, the new car speed is 10. Gear moved from 1 to 2. Accelerating, the new car speed is 50. 2 to 3. New car speed is 100. 3 to 4. New car speed is 120. 4 to 5. New speed is 155. Now notice what happens, because we have already moved to the fifth gear. So we are trying to gear up again. So that means we are trying to move to the sixth gear, which doesn't exist. So I'm going to press OK. Top gear reached. And since the top gear reached, it will not accelerate to 200. It will set the max speed as 160. Max speed reached, can't accelerate any further. Okay, now let's gear down. Gear moved from 5 to 4. Speed is 155. 4 to 3. Speed is 120. 3 to 2. Speed is 60. 2 to 1. Speed is 30. Then I move the gear from 1 to neutral. And the new car speed is 0. Finally, the ignition is turned off because of stop car. So I hope it is clear how properties and methods work. Now moving on to the last thing, which is events. Whenever there is a change in behavior or state of the object, you may want the caller or the object owner to get notified about it. These are done through events. You can call events as notifications in a layman's term. So, in short, class events are notifications raised by the class. Let's understand this using the example of tires. So, when a car moves, the tires, they wear out. In a new car, or when the car has new tires, there is no wear and tear in the tires. So let's say that condition is 100%. I mean, the tires are absolutely fine. And when the car moves, like I said, the tires, they wear out. So what we want is every time the car tires wear out, I should be, aware of what is the wear percentage. Also, when it reaches a specific percentage, let's say the wear and tear has brought the 100% to, let's say, 40%, then I should immediately come to know and I should get an alert that the tire needs to be changed. So let's fix it at, let's say, 40%. So let me quickly write the code and then I'll explain what I am doing. And we are done. For the sake of demonstration, I will use a lot of message boxes, but do not use them in a live scenario as it's not advisable. I'm just doing it for demonstration purpose, like I said. We have inserted a class called tire. In this class, I have a variable here which is called car tire condition. And in the class initialize, I'm setting its value to 100. This signifies the tire condition of a new tire. And here I'm using let and get to set and read the values of the tire condition. Let's move on to the gear class. We have declared an event here. What this will do is it will notify us whenever the gear is changed. And here we are raising the event. Notice that we can also pass along any useful values we want to send out to the caller. Here I have commented these two lines, and I'll explain why I have done this in a short while. In the let, I have added few lines. What I'm doing is I'm storing the current gear in the old gear variable, and I'm checking whether the old gear is not equal to current gear, and then I'm raising the event gear changed. Okay, let's move on to the car class. Here, what I'm doing is I'm catching the events raised by the gear class. To catch the events, the calling code, that is the car in this case, should use with events in the declaration. And here I have specified an event procedure which will be called whenever the gear change event, which is here, is raised. Also notice that the definition of this procedure must be same as that declared in the event, and you cannot deviate from this. If you go back. Now in this case, we coded the gear class because we knew the definition of this event. But this won't always be the case. So I would advise you to never type the definition of the event procedures. Instead, use these two drop downs on the top to automatically generate it. So the first one is the object drop down and the second one is the procedure drop down. Let's test this. I'm going to comment this. I'm going to press enter. Okay. And then from here, I'm going to select car gear. And you'll notice that the code automatically inserts the car gear change event. Now, why did it do that? Because there is only one event here. In case there were multiple events, then you can go ahead and you can select the relevant event. Okay, so I'm going to delete this and I'm going to uncomment this. So remember, do not directly type the definition of the event procedure. Simply use the two drop downs as I mentioned just now. Do you see this name car gear underscore gear changed? These two part names are separated by an underscore. The first part is the class name and the second part is the event name. And this is how the VBA code identifies that this is an event procedure. I've declared an object called car tire which represents my tire object. And in the class initialize, I'm initializing this car tire and the car gear. Let's scroll down. Here I'm using get and set. Till now we were using get and let, and I had mentioned earlier that I will show you an example on how to use set. So this is it. I had also mentioned earlier that the property let is used for normal data types, for example, string, long, boolean, double, etc. Since car tire is an object and not a normal data type, we are using set. Let behaves like dim. It assigns the value of an expression to a variable or property. If you're not sure how dim and set works, then I'll recommend watching the video dim versus set. Okay, let's scroll down. In the accelerate to procedure, I have made some changes. Here, I'm reducing the car tire condition by 7% for demonstration purpose. Here, I'm checking if the tire condition is less than 40%. And if it is, then I'm showing the tire condition and an alert that the tire needs to be changed. I'm doing the same thing in the next procedure, which is deaccelerate to. Here. Now let's move on to module 1. Here I have a variable to hold the value of the tire condition, which is car tire state. Here I'm checking if the tire condition is less than 40. If it is, then I'm displaying the current tire condition and then informing the user that the tires are being replaced. Now in real life, you may change the tire yourself, or you may take the car to a mechanic where the mechanic can change the tires. But for demonstration purpose, what I am doing is I'm changing the car tire using this line of code, which is set the car dot the tire is equal to new tire. When this code is run, this class initialize runs and the car tire condition becomes 100. That means we have got ourselves a new tire. And here I am informing that the car tires have been replaced. Finally, I'm showing the car tire condition, which should be 100. So let's run this. The Figo has been created. We have added fuel. The ignition is turned on. The gear moves from neutral to 1. And now see what happens. And we get a message box that the new car speed is 10. Also notice that the message box shows the new car tire condition. So what has happened is the moment we change the gear, the 100 value became 93. The 7 was reduced from it. So every time we change the gear, whether we move the gear up or we move the gear down, 7 will be deducted. Let's press enter. Now the gear is moved from 1 to 2. The new car speed is 50. Car tire condition is 86. We change the gear from second to third. New car speed is 100, car tire condition is 79. We move from 3 to 4, the new car tire condition is 72. 4 to 5, car tire condition is 65. And now we have reached the top gear. Max speed reached, can't accelerate any further. We will now deaccelerate. 5 to 4, tire condition is 58. 4 to 3, tire condition is 51. 3 to 2, tire condition is 44, 2 to 1, and see what happens. Now the new tire condition is 37, so it is less than 40, and hence we are getting the alert, change car tires as soon as possible. Gear moved from 1 to neutral, the car tire condition is 30, we need to change tires as soon as possible, it's a reminder. So we click on OK, now see what happens. Ignition is turned off. Now the car is still. Car tire condition right now is 30. We will replace the tires now. And the car tires have been replaced. The new car tire condition is 100%. So the tires were successfully replaced. So I hope it was easy to understand using this car example on how to work with properties, methods, and events. One quick reminder again, do not use message boxes in classes. I have used it just for demonstration purpose. In a live scenario, do not use it. Time for a quick recap. In this video, we learned about classes. What are classes? Why do we use classes? What are properties, methods, and events with respect to classes? In fact, I used a car example to explain things in a very simple way. But if you still have any questions, feel free to leave a comment in the comment section below. Or you can also email me on support@tamexcel.com. I also have a Facebook page. The link is in the description below. Feel free to join that. And if you have any questions, you can post it there as well. I'll be more than happy to answer your queries. So if you like the kind of content that I'm putting up, and if you would really like to support this channel, then watch a couple of videos, drop a couple of likes. And if you really want to learn Visual Basic Programming from scratch, then go ahead and watch the playlist, because that is where I have arranged the topics in a specific sequence. That playlist will definitely help you. And if you still have not subscribed to this channel, then go ahead and subscribe to this channel by clicking on the bell icon. And I'll see you soon with my next video, which will be about OOP, which is Object Oriented Programming.